Alright, looks like we're going live right now. Let's see, okay. So I did throw this stream up, very short notice because I just got the idea to actually do it. So one game that I've heard about recently is called Linux Air Combat. We're going live right now. Oh, hold on a second. Okay, so Linux Air Combat, as the name implies, is a air combat or flight simulator for Linux. Now, this is a game that was based off of a very old flight sim for Linux called GL117. And then someone else took over the project and then continued developing it to be a more general flight sim. GL117, I think, was named because it simulated the F117. But this version simulates much more, mostly focused on World War II. So the reason I wanted to do this was because this is a open source flight simulator. I just wanted to see that how someone else implemented a flight sim, and specifically how to develop like a game and game engine. But as the name implies, this runs on Linux primarily, and I downloaded the source code, tried to compile it. It doesn't work on Linux, or it doesn't work on Windows, which is the dev system that I'm using. But with just some minor editing, I was actually able to get it to run on Windows. So that's the basic amount of work I've done so far is mostly just commenting out all of the Linux-specific code and making sure this game actually runs on Windows. So maybe if you're really into the Linux and GPL community, this might be heretical, but I think it's quite funny to run Linux Air Combat on Windows. So I do have a version of it running already. I'm going to run that right now. Linux Air Combat is a multiplayer game primarily, and I had to disable the entire multiplayer system to get it actually running on Windows. Hopefully, eventually, we can add that back and maybe get cross-platform play. I don't know if anyone actually plays this game, and we'll see shortly just how difficult it is to work on this. But anyways, here's the game as it exists, pretty much with no changes. So the graphics in this are very, very simplistic, and actually, I can tell you right now, it runs on OpenGL immediate mode, or OpenGL fixed function pipeline, which is a really old style of writing graphics code. And as you can see from the flashing lights and this incredibly bare bones menu, this is very much programmer art, free software graphics design. It's not exactly the nicest thing to look at. Hold on a second. I can open up. There we go. Okay, so actually on this main menu there's nothing at all. The splash screen before that actually had something to look at, but here we just have flashing lights.
Welcome to Linux Air Combat. This is the piloting tutorial. Start here before you fly a mission. Leave the joystick centered. The fighter should fly straight on, and if not, recalibrate your joystick. Moving the joystick left or right will affect your ailerons, and your aircraft will roll clockwise or counterclockwise. Moving up or down will affect the elevator that's pushing forward or back on your joystick. You'll start to fly a loop when you change your elevator.
But this is
if your joystick has a rudder, you may alter the rudder's position, and you'll fly slightly to the left or to the right.
Convert this to run on Windows.
If your rudder is twisty, you just twist it. Your joystick has a throttle to speed up or decelerate. There's no way to entirely stop. If you get too slow, you'll stall. The buttons on your joystick can control all of your weapons and flight surfaces. You can make any button activate any control by editing the LAC-controls.txt file in the hidden.lac folder within your home folder. Edit that file with a text editor. I think you'll find its syntax self-explanatory. A summary of commands can be found in the menu
There are
Escape
some
will show the
interesting
menu
graphical features
and return
already,
back
like
to the
this
action.
sun
But
reflection
don't press it right now or you'll
ground.
lose this narration.
There was a major
Look at the
glitch in
radar on the
ocean that I
bottom
just
of your
passed
screen.
there,
It's a big circle.
but
There are enemies represented by
the game is not terrible, but it's also
by
not great.
points of light. A
Actually,
white
this
dot
glitch in
is
the
selected
ocean
and a yellow dot is not. Target an adversary with a configured joystick button, hat switch, or by pressing the appropriate button on your keyboard as marked here. Then, shoot the targets to complete this tutorial successfully. Please note that this is just the first of 4 very simple, rather primitive tutorial missions to get you started. The 2 targets in this offline mission are not very smart. They don't use any fancy moves, and they won't shoot back at you. It won't take you very long to learn everything you can learn from this very primitive mission. You might find you need more basic training.
Okay, that might fix the audio problem. I don't know why OBS is ignoring my system commands here. Okay, that might help with the audio. I have the audio completely muted on my end. I don't know why it's actually playing the audio on OBS. Anyways, but yeah, we have a working flight sim here. There's like terrain rendering, sky rendering, actual flight code here. This is if you've followed my YouTube channel, then you've seen that I do flight sim game development already, and I think this flight model is a bit more advanced than anything I've written. So this should be an interesting exercise in what other things are possible with the flight sim. By the way, this is floating, or this plane is mostly, or this game mostly focuses on World War II planes. So right now, I believe I'm flying some kind of warbird. I don't actually remember what it was. I can go back to the main menu and see what it was. So yeah, so this is actually a P-38 that I'm flying. As you can see from the graphics here on the bottom, the cockpit is not really rendered with all that much detail. And I don't know if there's a way to go into third-person camera. But that's not really that hugely important right now. But okay, so for an actual plan of what I want to do with this project, what it runs right now, it's basically just we can look at the source code here, and this will be a very programming-focused series. Pretty much the only thing that ships with the game is the game itself. So it's just one enormous pile of C++ files, header files, and it's all very Linux-specific, and it does one thing, which is render the game. And the reason I point that out is that there's like no testing, no tools, pretty much nothing there to actually like speed up game development. But I plan on adding that as well. So I want to factor out a lot of this code to put it into a separate engine so we can do stuff like creating a model viewer to view 3D models. Instead of having to load the game and then fly around, we can just view the models directly. And that's actually going to be a simplified way to render, or to test the rendering code that I'm going to be writing. But okay, let's actually look at the code right now. So I'm in the main.cpp function, and this will give you an idea of what kind of style this is written in. So the main function, as I scroll through the code, is 17,000 lines long. 17,000. And I'll be honest, most of this I've had to comment out because it was very Linux specific. And even worse than that, like there's a lot of hard-coded stuff here for individual planes. And probably the most egregious part is that like half of this code in main.cpp is actually specific to Mumble. So this game has Mumble integration, which is a very old-timey voice chat service. That's like the official voice chat integration with this game, but it's just mixed in with all this other code which is specific to the game. And it's just going to be an absolute pain to factor all of this out. And the author left this comment here, which also describes what kind of style this code base is written in. So, right here, most global variables are defined here at the top of main.cpp. And we can see all these global variables right here. Very worryingly, we have stuff like mission-specific variables, which are just recorded right here as global variables. All the stuff related to Mumble, like I said. Yeah, networking code mixed in here. All the stuff like flight models. Yeah, every single 3D model that's included with the game is just a global variable. Here's all the extra functions and variables that other source files provide. And then we actually reach the entry point. So this game was basically written, how should I say this, the most direct possible way to actually create the game engine, which means it's not very modular, it's not very extensible, and it's just kind of, right now, very painful to work with. And here we actually see there's OpenGL immediate mode code right here, just kind of mixed in with all this other code. There's all this, yeah, Mumble specific or multiplayer specific stuff here, all just kind of jumbled into the main file. So this is going to be a giant practice in refactoring an existing code base, writing modern OpenGL, writing modern C++, and just pulling teeth with C++ in general. As for the flight model that's used in this flight sim, there is a file here called flightmodel.cpp, but I couldn't actually find anything like the lift or the drag effects. Well, okay, here's the drag effects. So I'm not really sure how physically accurate this drag system is. But what I can't find is the lift function, where it actually calculates how much lift a plane has. But again, there's some worrying design decisions here. Something like all of these global variables here, which controls the player's plane, and I have no idea how that actually works with the AI planes or the network planes either, because this again should be a multiplayer game. It should actually allow multiple people to play over the network, and then it actually represents each other's aircraft in each other's games, so you can play with other people. But I have no idea how they actually managed to square that with their insistence on using a ton of global variables. And some other stuff here, like these hard-coded behavior for each individual plane type. Yeah, so we have like different drag factors here, which is hard-coded in this giant switch statement, which is not really an extensible way to do it. So another goal is to make this more data-oriented. Possibly like allow other people to define planes here. I don't really know if anyone else will ever use this code, but I just find it to be an interesting exercise in working with other people's code and refactoring it. So, again, one thing I've done so far is just commenting out all of the Linux and network specific code. So there's, that was just to get it running in C on Windows. But there is some interesting code that I've also looked at but haven't really touched that much. Like for example, this model loading code here, which is which loads 3DS files. So the models for every plane is defined as a 3DS file, which I'm pretty sure that's like yes, it stores a 3D model, but it's more like a digital content creation file instead of a like game ready file. So I also want to write like an importer and exporter for GLTF in order to like avoid running all this 3DS specific code at runtime. And by the way, I think 3DS is a proprietary file format, and I think this code just reverse engineers the file format into what was the simplest way to extract all the data they care about, but that's not really a good format to actually ship with the game. Now, that being said, all of these decisions they made on how the code base is structured and how all of this works, it does accomplish one of their stated goals, which is creating this code that can run on just about any platform. They even say that it can run on the Steam Deck and the Raspberry Pi. So that's going to be another goal, which is somehow maintaining this game to actually run on very low power systems. And I guess adding like graphical settings to allow you to change or to control just how complex the rendering is. Yeah, so they say here, LAC's extensive use of global variables results from its need to code for speed at any price. Global variables can be accessed immediately and arbitrarily from anywhere in the program logic at any time. That's 100% true. That is something you can do with global variables, but this makes it incredibly painful to develop, especially because I'm not the one who wrote that code originally. So I have to figure out all the different places that they use these code, all the assumptions they made. This is almost like a masochistic programming exercise. Yeah, it is essential that they be given clear, globally unique names for reference. So eventually I want to rip out pretty much all of these global variables and move them to something a little more object-oriented, encapsulated, a little less global, and something that's just easier to work with. And also, I'm not really sure if this is related to the OpenGL immediate mode, but this is only running at 60-ish FPS, which is incredibly low given how simple the graphics are. So, yeah, right now it's running about 67 or 68 FPS. That's not the speed that my monitor runs at. My monitor can do 144 or 60 FPS, so I'm not sure where this number actually comes from. I think that the immediate mode code is so inefficient that it's running at 60 FPS. Maybe there's some kind of VSync that's causing it to be inefficient, but I don't actually know why it's running so slowly. Given how simple these graphics are, I would honestly expect this to run at maybe 1 or even 2,000 FPS. But as we replace this with modern OpenGL code, that should be a lot faster to run. Actually, it may have some kind of VSync on, I don't know. I need to actually exit this game. But yeah, even though it's running at 60 FPS, it is actually making my graphics card fan spin up really quickly, so it must be doing something really inefficiently. I can actually check that and see if there's any kind of VSync that's running in the game right now. Or actually, this game uses SDL for its drawing layer, so I don't know how SDL controls VSync. Okay, so this SDL render hint VSync is not used anywhere inside of this code base. Okay, SDL create renderer, I'm pretty sure I did see that earlier, so. Maybe not. Okay, so one of the changes I've already started making here is moving some of this SDL code out of the game itself and into like a more modular engine system. So I've already moved this SDL window out here, and this is where it creates the window, and it creates the OpenGL context. But, oh, it's not actually using SDL create renderer. I guess that's like a... Yeah, that's like for using the SDL's built-in render command, so I don't think we ever use that here. I don't know how other what other method SDL uses to enable vsync. I really don't think vsync is on right now because it's running at such an odd frame rate. Okay, so all of this here is just recommending to use create renderer, which we aren't doing. Software rendering. Okay, I don't think it runs in using the create renderer method. So all I have here is the gl create context, and down here I have SDL swap window. Enable double buffering. Yeah, I don't think it's actually using vsync. But anyways, that's a kind of a minor issue right now. Okay, so an actual goal that I want to do maybe for this stream is just writing a 3D renderer that just draws models from this that are included with the game. So we can actually look through the source here. The game does come with several models of airplanes, which are stored in these 3DS files. 3DS is a proprietary binary format, so I can't actually inspect these files to understand what they're doing. We can at least use the existing 3DS model loader code and hopefully extract that into something that can be rendered with modern OpenGL. So we aren't going to touch the rendering code that's in the game right now, but we're going to create another folder here, which holds all of our like testing and tooling. And by the way, the original code base for this uses either make or code blocks. But one of the first things I did was define all this to use CMake instead. So we have a CMake file here that defines the project. It's pretty simple right now, and it's also pretty ugly because I did not use any kind of proper package management or build system. So if someone asks you the correct way to write a CMake file, it's not what I'm doing here. These are all just includes and binary files that I already have on my PC, and this is not a very efficient way to define a project. But we're going to just continue doing that for a while until I can actually change that over to using something like Conan. Okay, so we have our... We're just going to make a couple of new CMake files here. Okay, so we just made a new CMake file for that model viewer app. I don't know how this is actually going to be laid out, the build folder. So hold on, let's switch to debug mode. Nothing. Okay, so there's no actual code in this main file. Let's just write a very simple program right now. Oh, I need to include this on the root folder. Yeah, there we go. Okay, so we got our executable running, or executable compiling, and it literally does one thing right now, which is the hello world. But we're going to use this to create our model viewer. Okay. So I want to put a bunch of the code that's going to be used in the model viewer. It would just be part of the engine project instead of actually custom to model viewer. That means I need to actually include the engine include folder. Okay, so here we go to the meat and potatoes of C++ development, which is beating your build system into submission. I'm not actually sure why that's not reading this include folder here. Okay, see, engine include is being put in the wrong location, so that means I set up this CMake variable at the root folder incorrectly. Yeah, so it's putting engine include relative there. I don't know how to concatenate a string in CMake. Okay, so it's just incredibly simple. I don't know if that's the right CMake variable. might be this one. Yeah, if you're wondering what it's like to be a C++ developer, it's mostly just chasing down include errors like this. So I need to add a slash there to make sure this string concatenates properly. Okay, there we go. So I need to also include all of these include files for the project. I can probably put this into a single variable. Okay, so that solved all the include problems. Now I need to actually connect all the linker objects. So we have all these binary, hold on. I just realized I can make this text slightly larger. Okay, so I can include all these binary files for the linker to use. Yeah, I know there's riveting content here, but I'm just trying to solve all these linker errors now. Oh, it's not a linker error. It's because SDL is hijacking the main function. Okay, that's always annoying. There we go. Now it's building properly. Okay, so I have all of the include files and binary files for our model viewer. Now we have the task of building an OpenGL model viewer that can load and display all the 3D model files that are included with the game. So there are quite a few files we can use to actually test this. And also, okay, there's like a UI system that's included with Linux Air Combat. I don't want to use that. I want to use something like mGUI, D or mGUI, for all of the debug and development tools. So I need to also include that at some point. But just for right now, we need to create our OpenGL rendering engine. And hopefully I don't need to use the CMake list anymore. So we need to initialize SDL to use the video system at least. Not sure if we're actually going to need input like joysticks or sound. It's just a model viewer, so let's just stick to video for now. Okay, so we can actually start by making a window for the SDL from the SDL library. So we need a title, width, height, full screen. Just gonna put some simple values here for now. This should allow us to actually create a window that we can a window that an SDL window, but it's going to have no content and like only the very basic event loop for now. Actually, if we don't have a rendering engine set up, we can't even use poll event. We have to use wait event. Okay, so right now the only thing we're doing is waiting for the user to hit the X button and close the window, and then that will run the entire application. Oh, just kidding. I did not copy the SDL DLL files. Okay, so that's the other awkward thing about how I'm setting up the CMake here, is that I have to manually copy the SDL files from somewhere else on my computer to the runtime folder for the model viewer. So I had to set up these commands manually to copy over SDL2.dll, but we need to move that here in model viewer, so it's right next to modelviewer.exe. I could not figure out a better way to do it with CMake other than writing a custom command. That's a little bit sad, or rather, I just straight up don't know how to do that. So we're just going to copy this and hope that our cargo coding works. So, okay. Current binary directory should be the model viewer folder. So let's build this and see if it puts the, oh yeah, SDL2 is now located in this folder, so we should be able to run the program. There we go. We have a blank window that does absolutely nothing, but allows you to close the window. There we go. That is the start of our model viewer. So, by the way, this code is all located on my GitHub profile. That's github.com/Vosgries. So if you really want to, you can also look at this code yourself and see what I'm doing. I probably won't put all development on YouTube live streams, but if you're really interested in this project, you can still see what I'm doing. So yeah, here's the project. Linux Air Combat. My profile /Vosgries. Hold on, I just saw something interesting here. I don't know. That's alarming that there's a bunch of driver specific or graphics card vendor specific things to keep in mind. That might be just because they're using immediate mode. But anyways, okay, so back to the model viewer here. I have this main loop for the model viewer, which just reads this code, or just reads events from the window. It's incredibly simple. And eventually I want to find a way to move the while loop, the main loop, into an engine, which will be part of the engine library. Because right now there's also a main loop in the game. Oh, I need to close a lot of these windows. Hold on. Yeah, there is the main loop in this game, which again is just mixed in with all this other code in the main.cpp file. And actually, you can see here, the main loop is only defined 13,000 lines into the main file. Yeah, there's just so much code ahead of this. It's just all mixed in together. And probably one of the weirdest things here is that there's also gameplay specific code that's directly placed into the main loop. So again, I want to refactor all of this to put the main loop is like part of an engine library, and it's part of this engine module right here, which eventually gets compiled into both the Linux Air Combat game and all of the development tools that we're developing right now. But for right now, we're just going to have a custom main loop for this tool. Okay, so it's been so long since I've actually written OpenGL code, I don't actually remember any of it. I need to actually like look up all these OpenGL resources to figure out how to display even a simple 3D model. Luckily, we're not writing Vulkan code because that would be a heck of a lot more involved. OpenGL should at least be relatively easy to develop. So when you go back here, there's a lot of code we can add to that we're probably going to end up needing for our OpenGL. So let's define a model class and maybe a mesh class as well. Yeah, I think the way we're going to define this is that a mesh just contains 3D graphics data of a 3D mesh, and then a model contains a list of meshes and a list of materials to render those meshes with. So we're going to need a model class, a mesh class, and a material class at the very least. And again, there's already a bunch of OpenGL code in the Linux Air Combat game itself, but I don't want to reuse that because it's all immediate mode. So we're just going to be, for right now, we're just writing a completely parallel rendering system. And eventually, we're going to rip out and delete all of the immediate mode code and replace it with the model code that we are just now starting. So. Oh, you know what I actually need to add as well is OpenGL loader. Whatever. Let's just continue with this defining the headers for these classes right now. So we're using the namespace LAC engine. I guess we can call this the LACE engine. It's a nice little acronym. And we're just going to define some simple classes for right now. Okay, Visual Studio is trying to apply all of its formatting here. That's just annoying. We're going to ignore all of that though. So ultimately, a model is just going to contain basically a list of meshes and a list of materials. Oh, here's another C++ thing that we have to worry about here, which is circular includes. Or maybe not circular includes. I'm not sure if mesh ever needs to depend on model. But I know the model depends on mesh and material, so let's actually not worry about that right now. We're just gonna do this the most direct way possible. Okay, so we need to figure out what data we actually need to put inside of a mesh class. There's a lot of different data you could add. I'm not sure what's present inside of the existing 3ds model files. I think at a very basic level, they have position data, obviously, normals, and vertex colors. I'm not sure if they actually have vertex colors or if they use texturing. So either vertex colors or UV texture UVs. Yeah, we have a lot of target files here which define textures. I don't see plane specific textures though. So it's possible that everything is just colored using vertex colors. So basically we need to have multiple data streams here to represent all of the mesh data that we need. We can define that with an using an enum class to just write like a mesh data stream, which is going to be used to define all the mesh data that's going to be part of a mesh. So a vertex data class is going to contain some kind of vertex data, which I'm not quite sure how to represent that. Probably just a void pointer, because we don't know what actually format the data is going to be in until we load it at runtime, so we can't put a single type here. But we can at least define some stuff ahead of time. So position is going to be three-dimensional floating point. It's going to be another three-dimensional floating point. This is two-dimensional, and this is potentially four-dimensional if they use alpha coloring, which I think they do because there's transparent objects like glass. So there's probably alpha rendering, alpha blending. So we can't save exactly how much space or the exact type of any of these data. So we have to just store it in a void pointer for now. And also for material, I have no idea what we need right now. This will probably contain stuff like specular or actually I have no idea what data is already defined in the meshes, so you just have to figure that out eventually. But yeah, right now our model contains meshes and materials, and the meshes themselves contain multiple vertex data streams. And also, the data isn't going to live on the CPU, so we only need this data here like temporarily until it gets uploaded to the GPU. So we can actually, and eventually like OpenGL stores all of this as integers, I believe. We'll figure that out later. But anyways, we need to actually add the source files for all this now. Ooh, I hate how it formatted this. I don't want these header files here to begin with. Okay, so we need to add constructors for all these types. Okay, I need to do the thing that I've been avoiding, which is actually relearning how all of this OpenGL code works. And frankly, learn OpenGL is probably the best source for this level of what I'm trying to do. So yeah, that's what this live stream is going to be. I'm going to be reading documentation and then writing code. Okay, actually, you know what? We already have the source code for 3D model loading in 3ds.cpp and .h. I should probably move these to the engine folder because it's going to be like the common code that's going to be used everywhere. So putting it inside the game is no longer necessary. Yeah, I put it inside this extra project 3D model loader. This is no longer necessary. Yeah, so the only hard part with this is that it is still mostly written with an understanding of how this is like very specific to how LAC works. Yeah, and it also uses the model code right there. That's actually going to be complicated. Basically, what I want to do is extract all of this 3DS specific code, just have it be able to load data into memory, but not necessarily put it on the GPU. What's inside the model.h? Yeah, it's all very specific to LAC here. Oh, yeah, this is going to be, yeah, just refactoring this 3ds.cpp is going to be quite a bit of work. Okay, so long term, what I really want to do here is like write an importer that takes 3ds files and then converts them to GLTF or some other mesh format. So all of these like C materials and C objects, these are LAC specific classes. I need to make this a little more general so that it's just it reads it into some kind of in-memory data structure, which isn't necessarily ready for rendering, but can be then processed and like written to a GLTF file. And all of these error markers are because of this model.h file. Or a lot of them are defined in model.h, which is where we define stuff like C vertex. It represents a vertex which may take information about color, location, normal, texture, and number of surrounding triangles. So this is roughly the vertex format that they're working with. We have position, normal, and textures, and color. So vector 3, vector 3, vector 2, then C color, which is, oh, this is not actually floating point numbers. So these are unsigned integers from 0 to 255. So that's the vertex data that it's used pretty much universally here. Actually, I want to make this, here's the mesh data. Like this is going to be, this will tell the rendering engine what the data is used for. But I actually want to set like another enum that actually describes the format. And actually there may be, I think there's already OpenGL enums that basically define this, but let's just go ahead with this for now. Now let's just define the types that we know that we're going to have. So it's going to be a vec3, vec4, a vec2. Then we have uint 8 vec4. Yeah, we're probably going to. Okay, so that's another library that I need to get in. I need to add to this project. I don't want to use these C vector 3s. I want to replace that with like a GLM or something. So actually, I need to figure out a way to actually load all of the like GLM project into CMake file, and I don't want to do it the way I've doing it already. So hold on, let's. Okay, it's going to be a little bit messy, but I want to actually undo moving this file for now. Okay, so we're not going to actually move the 3DS file until much later because that is a very extensive change. So what we have right now, we may as well commit. It's the basic skeleton of the files we need. Again, we're going to have to do a lot of CMake stuff here in order to load all these libraries. So I want to use CMake and Conan to actually load all these dependencies. I need to make sure that the dependencies we have are actually part of Conan. So I know SDL. What the heck? Okay, SDL and SDL Mixer are loaded onto Conan in some form. That should be fairly easy to then add to our project. We also need something like GLM to be here. Conan O'Brien. Yeah, he's not. I don't think he does much C++ development, but yeah, GLM is also located on here. So if possible, I want to stick to libraries that are located on Conan.io. Okay, this search page is absolutely terrible. Okay, that's nice. I just Googled how to solve a CMake problem, and immediately the first result is deprecated. Oh, the new under development integration is located here. So the existing one is deprecated, and the new one isn't finished. That's a very nice state to be in. It's a lot like developing in Unity 3D. There's just all the legacy stuff and all the new stuff that isn't finished. So there we go. Okay, I know I've done this before, and I don't remember if I need to actually have Conan installed on my PC. I don't know if I do. No. Oh god. Okay, so this entire stream might just be developing CMake files. I don't remember how to actually do this. So yeah, here's the documentation. CMake wrapper for Conan, C and C++. Yeah, this is what I was expecting here. So a Conan.cmake file, which would then allow us to just download libraries from Conan. What on earth is this syntax? Okay, hold on. Do I need to install Conan to actually use this? Oh my god, it's a pip. It's a Python program. Amazing. Windows does not recognize this app. Whatever. There we go. So we do have Conan installed. I think that's definitely needed by the CMake integration. Okay, you know what? This CMake integration is going to be incredibly dull, like even more dull than C++ development. So I'm just going to end the stream for today, and maybe tomorrow or Saturday or Sunday, I'll continue doing the stream when I actually have OpenGL set up that I can use. So thanks for joining today, and that's the end of the stream.